we have little to no connectivity between these chains. It results in a degraded user and developer experience. So we want to solve this. We want the connectivity between the chains to be more seamless. And the problem is so big that we have a whole event dedicated to this problem and solutions around it. Um, so we like to talk a lot about how cross-chain user experience is bad in the space, but something that's not talked about a lot is how the cross-chain application development is even worse. Some of the problems related to that is a big protocol engineering overhead that you have to go through when you are building a cross-chain application. So on top of building the regular application logic, you also have this additional layer that handles the messages from different chains and also different edge cases around different dependencies. Another is like you have to also deploy on multiple chains that you want to support. So instead of having to deploy on a single chain and maintaining your dependencies there, you also have to maintain your dependencies on multiple chains. So for example, if you write your application on chain A using an oracle that is the most popular there, and you want to deploy your application on chain B, you quickly realize that maybe that oracle is not available on that chain. So now you have to rewrite your code, do a lot of other refactoring, and then you add audits and bugs on top. So it just makes the process of developing an application very, very complicated in the cross-chain world. And to us, the problem is very personal because previously we were building a cross-chain application, and it was really, really hard for us. And this is probably why we haven't seen any other meaningful cross-chain application beyond simple token bridges since the inception of generalized message passing protocols. So it really feels like we are in the Bitcoin era of interoperability instead of like being in this post-Ethereum era where transacting on chain is really simple. So this is more or less how a single transaction across chains flow on a bridge. So you start from chain A, interact with an application. That application sends your logic to the bridge gateway that then sends the payload to the bridge committee, which then sends it to the bridge gateway on chain B, which then sends it to application and then to the users. So this really is like you're extending this concept of transaction across multiple chains. Transaction historically has been this single chain primitive, and when you try to extend that beyond a single chain, it just you get a degraded performance with user experience, developer experience, and security overall. Um, so we have a lot of solutions trying to solve this problem somewhat more so from the bottom up approach, meaning instead of so how they really work is that a chain has to opt into this protocol to be able to get access to the networks or chains from with networks and chains existing in that particular protocol. And the problem of scalability with these kind of approach is that you you have to they're reliant on network effects being available. So now it's becomes really hard to coordinate or uh, make sure that all the chains are opted into the same protocol. So what this ends up looking like is it's more of a social coordination problem, which is almost impossible to solve. Instead of being this technical problem that is practically solvable. So these could include like shared sequencers, super builders, ag layers, etc. And a good example that I can draw is the parallel between IBC and layer 0, where IBC required chains to opt into their protocol to be able to get access to or to get connected to other chains and using that protocol. But layer 0, they could basically just go and push the code on all the chains that they wanted to support. So this basically we know how which ended up getting more adoption or so. So with this approach, so we will end up from a world of fragmented chains to a world of fragmented ecosystem where it becomes somewhat easier to transact within the chains within the same ecosystem, but the same problem persists when you try to perform transactions between the chains with different ecosystems. So as someone on Twitter put it, like, I really like the line, if there are multiple ag layers, there's no ag layer. And we're seeing multiple ag layers being built by multiple ecosystems in the space. So at Twine, we really thought about this from a top-down approach, where instead of wanting the chains themselves to interop or to integrate in our protocol, we build an L2 that settles on multiple chains to be able to aggregate liquidity from all these chains into a single execution environment without actually introducing any new consensus or trust assumptions on top. Um, so now we could settle on Ethereum, Solana, Bitcoin, Celestia, or whatever chains, and aggregate liquidity from all of them into Twine. So yeah, we've been flooded with a lot of L2s in the past year or so, and moving in the same direction of building yet another L2. It doesn't feel like the right direction in a glance, but the problem is not that we have a lot of L2s. It's just that we have a lot of identical L2s, and yeah, like for us, the reason that we want to build is different from what a lot of other existing L2s are in existence for, and we are trying to be better than that. So yeah, as my friend Wade I likes to put it, we don't need more infra, we need better infra. So this is the infamous modular stack diagram made famous by Celestia, which involves execution layer, settlement layer, and data availability layer, which together makes up a blockchain. And yeah, this is VCs throwing money at whichever pitch deck that has this diagram in it. So here we go again. And in the past year or so, we've seen a lot of experimentations on execution layer with things like movement, Eclipse, Fuel, a lot of the alt VM L2s building. And then we also have experimentations on data availability layer with things like Celestia, Veil, EigenDA, etc. But little to no experimentation, at least to our knowledge, has been done on the settlement layer of the stack. And this is where we're trying to innovate on. So what exactly is settlement? Settlement might just be one of the most misunderstood term in the space. And if you go ask like 10 different people what settlement is, you might end up with 10 different answers and even more confused than what you initially started out with. Um, to us, it's very simple. It's a process of utilizing another chain's consensus to store your chain state and building a protocol around it so that you could update the chain state given a valid proof of transition. So you also add some forced inclusion mechanism for censorship resistance and all of that stuff. So this basically means that there's no additional consensus involved in determining the state of the L2. So, which then means you could build a canonical trust minimized bridge from the base layer into the L2, which helps you in bootstrapping liquidity and community more easily than what you would have to if you had to like build your own L1 from scratch. Which is also why we're seeing this rise in number of L2s these days. So this is the single chain settlement paradigm. So when you extend that to multiple chains, what it ends up looking like is that you store the state of an L2 on multiple chains instead of one, and you have the same state update protocol on all the chains, and then you have this canonical bridge from all these base layers into this execution environment, the L2, so that now you can aggregate or tap into the liquidity from all of these chains in a more seamless fashion. So this is enabled by what we call meta-consensus, which mostly comprises of two main components, proof of finality and proof of singularity. And both of these combined, they allow us to coordinate multi-chain settlement. So proof of finality is basically an aggregated proof of consensus of all the chains that we have in the system. So with a single proof, a chain can have a view to the states of all other chains in the system. So it can be used to verify the cross-domain transactions that has occurred in a particular batch for Twine. And then the next is proof of singularity, which is used during equivocation of the state. So in case there's disagreement about state of Twine across different chains, proof of singularity acts like this synchronization gadget for the protocol. So in every few batches interval, what we do is each of the chains is assigned with a voting weight. And if there's ever a disagreement about the state in the protocol, you basically generate a proof of singularity, which aggregates the state of all of majority of the chains according to the voting weight, and then you enforce that onto the chain with the state that is not in agreement with the majority, which then enforces the state to be in sync with the majority. So this way, like, we can basically aggregate the security of the majority of the chains that is involved in the system, meaning to be able to be malicious about the state of Twine, majority of the chain themselves in the system have to be colluding instead of just one. Okay, so what's really exciting to us about this is that this allows us to unify the fraternity of the blockchains in the space, namely Bitcoin, Ethereum, Tron, Solana, and this is really not possible with opt-in or bottom-up approach where where the chain themselves have to opt into the protocol. So the way we really see it with this the relation between bottom-up approach and top-down approach like Twine is that we will be able to connect these different major ecosystems, while a lot of the long tail chains would be utilizing these bottom up approach for interoperability within their ecosystem. And now I want to also touch upon like how this also means we're building a better version of a centralized exchange. For that, let's start out with building an L1. To do that, we start out with a committee, forming a consensus, adding some sort of censorship and reorg resistance mechanism on top. You also add execution functionality, although that's optional for some kinds of L1. When you separate out execution from the L1 itself, you end up with an L2. And between multiple L1s and L2s, if you want to send a transaction between chains, you end up in a world of bridges where they have this committee that's attesting to the transactions between these chains. And the caveat, though, is that in the process, you end up losing the security of the original L1s because you have to trust the committee or the consensus of the bridge that it is performing or like validating the transactions honestly and not basically stealing the funds. And when you move from the world of bridges to centralized exchanges, you still have a committee, but the committee is a one-man army. And over the years, if there's one thing that we've learned, it's that it's not good to trust one-man armies. And in centralized exchanges, you also have some sort of limited executional functionalities, and yeah, so like you could perform things like swaps, lending and borrowing, etc. But there's no platform for developers to build their own applications or so. So when you move from the world of centralized exchanges to the world of Twine, what you end up with is this. You end up getting the original chain censorship resistance and consensus back, and then also have this fully fledged execution layer. This means Twine is a trust minimized, non-custodial, and a programmable version of a centralized exchange. This is really exciting because now on Twine, any developers can deploy their single chain application, and now users could perform swap between ETH and Sol, ETH BTC, etc., without just like they would in a centralized exchange. So as much as I would like to say that we are working towards onboarding the billion users on chain, I know that a lot of the startups that said this in the past few years or so are nowhere to be found today. So I'll just stay to being more pragmatic and say that we are working towards onboarding centralized exchange users on chain as our first step, and bring in more or like net new users, TVL, and liquidity on chain rather than fighting for the same old set of users. And yeah, like I want to end this talk by saying that, we're so dependent on centralized exchange as an industry, and so reliant on them that we really can't be seriously saying that we are here to replace or onboard TradFi until we get rid of these or like at least minimize its impact on the space. So thank you very much. We are probably working on one of the most exciting ideas in the space, and we're hiring across all levels of the stack. And if you're interested, please feel free to reach out to me in Telegram. And yeah, thank you very much.